Hello everyone, welcome to Exploring Diana YouTube series where we explore the powerful capability of the Diana one step at a time. My name is Solmaz and today I will go over 3 different simulations on concrete gravity dam. This video is based on the tutorials that already exist on Diana website. At the end of video I will show you where you can find the tutorials. Let me explain the problem and after that I will jump to the Diana environment to start the simulation. As you can see on the screen, I want to model the three-dimensional concrete gravity dam by considering the foundation and reservoir. In the first step, I will conduct a response spectrum analysis of a dam to find the fundamental mode of dam by considering 2 different initial conditions. The first one, I will conduct the analysis based on the dam and foundation, and in the second analysis, I will do with the whole couple system, I mean the dam, reservoir, and foundation. After that, I will move to the second analysis to find the Rayleigh damping parameter, and the output of the second analysis can be considered as an input for the last one, I mean the time history analysis of a gravity dam. Let me move to the Diana environment to start the simulation. At the first step, I need to create a project. So I call it a gravity dam. Let me choose the destination folder. And in the analysis box, Diana offers you different type of analysis that you can select. For now, I want to select the structural and fluid structure interaction. It's a 3-dimensional problem, and I will consider the 1 kilometer for the model size, and for the meshing type for this video purpose I will select the quadrahedron or hexahedron or quadrilateral meshing type with the linear meshing order. I will press the OK button and just wait for a second until Diana create the project. Just wait for a second now. Now Diana create the project. After that, I will come to the unit and check them. Yeah, all is good. Now I need to create the geometry at the first step for the simulation. In Diana, you have 3 options to generate the geometry. The first one is using the action toolbar and using the creating option. The second one is using the command console and inserting the Python code. And the last one is using the option to import AutoCAD file. For now, to save time, I prefer to using the second option by importing the command Python code in the command console. So for this purpose, I just copy and paste the code to the command console. As you can see by this in this stage, I generated the geometry and add the color to each element. After generating the geometry, I need to assign the material properties to each element. So let's start with the foundation. In the element class, Diana automatically filter the element class based on the analysis type and the type of the elements that you use for the generating the geometry. So for now, we only have 3 options. I will select the structural solid, and for the material, I call it rock. In the class of rock and soil and rock, I will select the linear elastic isotropic. And let me bring the window. Yeah. Now I need to input the parameter for the Young modulus. All this data is based on the tutorial. Poisson ratio, and in this video I want to focus on the dam behavior. So I want to consider the foundation as a massless foundation, and I will press apply, and the material is assigned to the foundation. For the dam and reservoir, I will need to do the same procedure as I did for the foundation. So to save time, I add the material properties for the fluid and the reservoir by importing the Python code. Yeah. Now in the material toolbox, I can see the fluid and concrete. Let me check. In the dam, the material is a concrete and the structural solid element. For the reservoir, I need to select the fluid, apply, and for the foundation is a rock. Yeah, everything is good. Now let's move to the next stage. In the next step, I want to constrain the all outer face of the foundation. So let's start with the plane that planes that are normal to the x direction. I call it support x. Let me set the support name, support, and for the target I will select that face which are normal to the x direction. And now I need to fix the T1. The second one is support the y. I select the faces normal to the y direction and fix the T2. And for the last one, I call it support Z, and I will select the faces normal to the Z direction and fix the T2. Yeah. And let me show you the material properties for the fluid. In the fluid material properties, Diana offers you the two different options. The first one is compressible and the second one is incompressible. In this video, I selected the incompressible. So based on my selection, the Sommerfeld boundary condition is not applicable here. And I need to fix the free surface and back surface of the reservoir. For this purpose, I will come to the fixed head option and select and define the set and select the free surface and back surface of the reservoir. Okay. As I mentioned in the first slide, I want to consider the fluid structure interaction and soil structure interaction. For this purpose, I need to define some interfaces between elements. The first one is fluid structure interaction. I use the connection option in the diagonal. I call it FSI. The type is the interface. And for the source surface, I want to select the upstream face of the dam, and for the target, I select the downstream face of the reservoir. This element class is the fluid structure interface, and for the material, I call it FSI, and input the fluid density. I will click on the create. The second one is related to the reservoir and the foundation. As you know, the degree of freedom in the reservoir is only pressure, which is different from what you can find in the foundation. So we need to separate the reservoir from the foundation. For this purpose, I will click on the connection. I call it this. It's the type is disconnected, and for the source face, I want to select the interconnected face of the foundation, and for the target, I want to select the bottom face of the reservoir. Now the only one step remains. Okay. Based on the interface that I assigned to the dam and the reservoir, I mean the fluid structure interaction, the lower edge of the lower edge of the dam on the upstream side is disconnected from the foundation. So I need to reunite the dam and the foundation together. So for this purpose, I call it SSI, soil structure interaction, and in a type I want to select the unite. Click on the auto and select the foundation and the reservoir to reunite them. Okay. In the left toolbar, you can check what you have done up to now. You define the geometry. I define the geometry, material, supports, and the connection, which are fluid structure interaction, soil structure interaction, and disconnecting between the reservoir and the foundation. So only we have only two steps until the analysis setup. The first one is the load, and the second one is the meshing properties. So for the load, at the first step, I want to assign the self-weight load to the whole system. Let me set the load case. I call it self-weight. The second one is hydrostatic pressure. I call it hydro. Let me set up the load case. And I want to assign the load to the phase. Let me select the load type, hydrostatic pressure. And in Diana, you don't need to define a function to assign the triangular hydrostatic pressure load. When you select the related phase, Diana automatically apply the triangular load to the selected phase. So let me hide the reservoir from the geometry. And for the targeted phase, I want to select the upstream phase of the dam and the interconnected phase of the foundation and the reservoir. And the hydraulic head is 100 meter. Create. You can see the triangular hydrostatic pressure load. And the last load that I want to assign to the system is a base excitation. Let me set the load case for the base excitation. And in a load type, I want to select the base excitation. I input the uniform translational acceleration minus 9.81, and the direction I want to apply the base excitation in a stream direction, I mean the x direction. Create. In a load tab, you can see the combination, load combination. The first one is only self-weight. The second one I want to consider the self-weight plus hydrostatic, and in the load combination here, I want to have only the base excitation. Now to analyze the response spectrum analysis, I need to assign the frequency dependent factor to the base excitation. For this purpose, easily I can copy and paste the response spectrum data from the Excel. Yes, you can see the spectrum. Okay, and the last step before setup analysis is the mesh properties. For this purpose, I want to select the whole geometry. I mean the dam, reservoir, and foundation. And the seeding method is the element size. And for this video purpose, I want to consider the 40 meter for the element size. Let me press the apply, and now I want to generate the. Now I move to the last step, I mean the setup, the analysis. For now, to save time, I will show you the model that I prepared it before for this purpose. Okay, just explain what I did, and in the analysis setup, I defined the three different type of analysis in the analysis toolbar. I took advantage of the phase analysis in Diana. In the phase analysis, you can define which elements and interfaces or supports take part in the final result. For the first analysis, I want to show the result only related to the dam and foundation. For the second analysis, I want to consider whole coupled system, and for the finding Rayleigh damping parameter, I want to consider only dam and foundation and its related support. Let me show you the final result. For example, in RS1, I only consider the dam and foundation. You can see the 10th mode of the first 10 mode of the system. For example, the 6th eigenfrequency mode, you can see this deformed shape. For the second response spectrum analysis, by considering the whole coupled system, dam, foundation, reservoir, you can see the different deform and different eigenfrequencies. And for the last item, the Rayleigh damping parameter, let me show you the output file. In the output file, at the end of the output file, you can find the mass factor and the stiffness factor for the Rayleigh damping parameter. These data can be considered as input for the last analysis, the time harmonic analysis of the concrete gravity dam. Let's move to the last analysis. For the last analysis, I need to define two adjustments to the model. The first of all is defining the Rayleigh damping parameter. Let me add the number based on the output file. And the second adjustment is related to the load. As you remember, in a first analysis, I assigned the frequency factor to the base excitation. Now for the time harmonic analysis, I need to assign the time factor to the base excitation. For this purpose, I just need to copy and paste data from the Excel file and to the time-dependent factor table. As you can see, it's an earthquake that I want to apply to the model. These are just only two adjustments that I need for the last analysis. Let me show you the ready model to save time. For example, I consider the dam, foundation, and reservoir, the whole system with its supports and the fluid structure interaction. In a start step, I consider the hydrostatic pressure and the dead weight as a starting initial stress and additional load. And let me show you the result. For example, you can see the result of the dam in a different time. As you can see, also you can define the control limit in a properties toolbar. For example, you can define the different number to the model. And these are the data. And also you can set the selection mode to the node and select one node on the dampers and show the table. As you can see the deformation of this point on the dampers during the applying the earthquake to the whole system. Also, you can select the second node to see the differences between displacement for this node. You can see this node with the different colors in this window. Now I want to show you how you can find the tutorials in the Diana website. You please go to the tutorial section, and based on tutorial type, analysis type, and the module requires, you can see your preferred tutorial. For example, in analysis type, I want to select a structure response spectrum. And now you can see the response spectrum analysis of the gravity dam tutorials. Thank you for your attention. Please subscribe to the Diana YouTube channel and don't forget to tune in for the next video.